we're going to start with 11 through 19, and what we're going to do is we're going to find the geometric mean. So we use this little formula, and we would cross multiply. What you're going to know are these two numbers here, the A and the B, and we're going to have to find the X. So I'm going to give you an example, and what you're going to end up doing every time is taking the square root. Okay, what are you going to end up doing every time? Taking the square root. So simplifying that's probably the hardest part. Let me start with an easier one, like that has a perfect square. Let me see. I'll do 9 and 4. Yeah, but number 11. We'll look at number 11. So they give you 9 and 4. The way you would set this up is like that, right? I plugged in my A and my B, the two numbers that I know. And what you do cross multiply, really you can skip that step of setting it up like that, because every time you cross multiply, you get x squared, and what's 9 times 4? 36. So this is when you have to take the square root. Remember, I need just x. Well, they give me x squared. What's the opposite of squaring something? Square root it. Okay, do we remember that? Yeah, a little bit. Algebra 2, they're doing that a lot right now. So we square root both sides. So what is x going to equal? 6. Okay, that would be, and that one's an easier one because it's a perfect, 36 is a perfect square. Okay, what if I had, I'm trying to find some that I don't already have. 27 and 3. If my geometric means were 27 and 3. Again, you don't have to write that step. You could just go straight to x squared equals, what is 27 times 3? 81. Then what would I do? I would take the square root. So what is x going to equal? 9. That would be my geometric mean. Okay? And that's it. Let me see which ones you can do.
So are we doing this lesson? Or are we
finishing this one, and then the next lesson's really short. Okay? It's like I taught Sky in 5 minutes. The whole lesson.
That's Sky.
No, but I know, but it wasn't bad at all. So y'all can handle that lesson. There may have been a couple that I didn't do with her, but you'll be fine. Now, before you can go on doing some of these, I want to give you one where it doesn't end up like that. But does everybody understand what we're doing? You're basically multiplying the numbers and what? Square rooting them. So let's pretend that we have the numbers 6 and 15. I want you to find the geometric mean. That's how it's written on your paper. So I would write x squared. I'm skipping my first steps now, right? What is 6 times 15? 90. Now, if I square root that, right, x would be the square root of 90. Is that a perfect square? No. But this is something we need to go over. Is there a perfect square in that number? Okay, let's list some of the perfect squares. 1, because of 1 times 1. What's another one? 4, because of 2 times 2. What's another one? 9, because of 3 times 3. And I could keep going, right? These right here, I'm going to, 7, 8, 9, 10. Okay, those are all perfect squares. Do any of those numbers go into 90? Which one? 9. 9 times what is 90? 10. So watch, I'm just going to rewrite that. Do y'all remember doing this? Not really, simplifying square roots? I think the problem is, in Algebra 1, we don't really get to square roots because it's like chapter 10 or so, and I think we barely get through chapter 9 because of time. And then by the time you get to Algebra 2, they assume that you know how to simplify square roots. So we've got to go over this some today. But does everybody know that 9 times 10 is 90? Do we understand that? Okay, so I'm just going to write that in here. It's the same thing, right? 90 and 9 times 10. Now, do y'all know the square root of 9? It's 3. And there's my square root of 10. If you're on the ACT, this would be your answer. This would not. It's simplifying it. Like if I said 4 out of 8, would the ACT have that as an answer? No, what would they have as your answer? 1/2, right? It's simplifying the fraction. It's reducing it. That's the same concept here. You might get the square root of 90, but guess what? That's not simplified. They want you to break it down. 3 square root of 10 is actually your answer. So let's do another one, okay? And a lot of times, like if this one's on the test or whatever, I don't mind writing these numbers down. We still do that in Algebra 2. I list all your perfect squares so you can see what number to use. But you can always do that on your own paper, right? You could just list them. What do 4 and 18? Those are your two numbers, 4 and 18. Well, what is 4 times 18? 72. What is 4? 72? Okay. Is 72 a perfect square? No, it's not. So is there a number over here that goes 72? But is there a bigger number that goes into 72? You want to find the biggest one. It's 36. And I knew that there was another one because if I did 9 times 8, isn't there another perfect square in 8? 4. See, that's how I knew that number's not big enough. It's 36. Okay, so let me rewrite that. I'm trying to find the square root of 72. And that is what? 36 times what? 2? 36 times 2. Okay, what is the square root of 36? And then I still have my square root of 2. So do y'all see how that would be my answer? Yeah, we kind of getting it? That's a lot to learn, just that by itself.
What if like the number wasn't 72? What if it was, so that 36 is the square root. What if the other number was also a square root?
This one right here? Mm-hmm. Then you didn't pick a big enough number to go into. Like if you can still see, man, I have another perfect square in there, you didn't pick a big enough number. Which you could keep going, or you could just kind of start all over and see, wait, what other number would go into 72 or whatever it was. Let me find another that's not on your paper. They do 3 and 16. 3 and 16. So I'm going to have x squared equals, what is 3 times 16? 48? I think. Then I would take the square root of 48. What number goes into 48? Well, we already said it. 16 and 3, right? That one was kind of, is already set up for us. So it's 16 and 3. What's the square root of 16? 4. And then here's my square root of 3 left over inside. Do y'all want to try a few for a second? Okay, why don't y'all do 12 through 16. I already did number 11. So y'all try 12 through 16. And y'all, they could have a perfect square. I don't know. They could have one. So you can always put it in your calculator and see, like if it's a really big number. Okay. Here is this theorem. If we have this triangle and we have the altitude, that's what we started in the beginning of class last time. We were given an altitude in our right triangle. This is what the picture looks like. Now, if I have that, then I know the proportion, you might not can see it, that they have written right here. I would know that this little segment AD over the altitude is equal to the altitude over this segment. It's basically a geometric mean is what they're saying. So you would say this segment over the altitude equals the altitude over the other segment. It is the geometric mean. So let me do an example. Do I want that one yet? No, not yet. So let me look at I'll do this picture. if I have this triangle, here's my altitude, okay? That's the height of the triangle. And they give me some information. I know that this segment is 12. This segment is 4. This is Y. And this is X. I can't actually use that one yet. Can I? Hold on, I think I'll give you this other rule before I can do that one. Yeah. All right, here's your other rule then. All right, so first of all, in the other thing, I said that AD over the altitude equals the altitude over the dB, that segment. This one's another one, another theorem, and this one says that I can take the whole length of this, the AB, over this side, all right, and it's equal to that side over the little segment next to it. I know that's confusing. So the whole thing over this side is equal to this side over the little segment next to it. It's confusing. I'll just go over it with some examples and some numbers, okay? And I don't really think that I put many of these on the test, unless I can find an easier problem. All right, so let's just try the one that I wrote down. So I have, what's the length of that whole long side? That's what I would say in first. 4 and 12, which is what? 16. So I have the length of the whole side, and I put that over, let's say, this little side X. Then we use that little side X again. It's like a geometric mean. And what's the little segment next to it? 4. Okay, so you're saying the length of the whole thing over whatever the side you're looking for, and then the side you're looking for over this little segment. It's like basically talking about your two triangles. I'm saying, here's my big triangle. The side is this, and over this side. Do y'all see that? Then if I look at my little triangle, I have X, and what's the other side that I know with it? 4. Do y'all see that? It's kind of taking the big triangle and the little triangle. And you have to set it up in the way of the geometric mean. Now we just cross multiply. Same thing we just did. X squared equals, what's 16 times 4? What is that? I'm guessing 64. It's got to be a perfect square. Then what do I do? Square root both sides. What's both sides? What's the square root? 4. 8. So that's our X value. It's 8. Okay? Then I can find, now that I know my X, then I can do the first rule that I was saying, okay, to find the Y. Is everybody good with finding the X? This little formula, I know that's just hard to remember that. So now going back to the other one, it says, I'm going to take my little side here over the altitude. All right, this is the formula I'm using. They may say it. Let me read how they say it. But it's the little side over the altitude equals the altitude over the bigger piece. They say multiply the segments of the hypotenuse and the altitude. That's actually much easier. I could just do it that way. All right. What is your altitude here? Y. Does everybody see that? So they just say if you multiply that times itself, and what are the segments of my hypotenuse? The big triangle. 4 times 12. What's 4 times 12? 48. Is that easier than the formula? Using the rule that you just square the altitude and set that equal to multiplying the two segments. Yes, no, is that easier than the formula? You just say y squared equals those two segments being multiplied together, 48. Now, how would I solve that out? Y squared equals 48. How do I solve for y? When you have a square, what's the opposite of squaring something? square root it. So I'm going to bring it down here. Y equals the square root of 48. Is there a perfect square that goes into 48? What is it? Anybody know? 8's not a perfect square. 4 does go into 48, but a bigger number. 16 and 3. 16 times 3. What's the square root of 6? Square root of 16. So my answer would be 4 square root of 3. Let me see if there's another way I don't know if there's an easier way to do that one. Okay. I've got my triangle. We may do some from the worksheet together. Here's my altitude. And I have my links here, 4 and 5, and I'll find x. Oh, the altitude is y. Let's find the altitude one first. I would say I just square the altitude. What is that? Y squared. So I can find my y. And then I multiply my little segments right here. What's 4 times 5? 20. Now what would I do to solve for y? Square root both sides. What is 20? Like what times what is 20? That might have a perfect square. 4 and 5. And so what is the square root of 4? So I get 2 square root of 5. That's my y. Does everybody understand that one a little bit better? I think that's easier than the formula they give you. Okay, so that's how you would find the altitude. If you need to write that down, that's finding the altitude. Okay? You square the altitude and set it equal to those two segments being multiplied. Now let's go back to finding x. So remember, I take the length of the whole thing. What's the length of the whole thing? 4 and 5 is what? If I add them together, 9. So I put 9 over x. And then now let's look at the small triangle. X goes with the what? 4. Okay, so it's kind of saying, let's look at our big triangle. Now flip it and let's look at our small triangle. Does that kind of help you see? I'm trying to think of different ways to tell you. And then we do the same thing. It would be x squared equals what? If I cross multiply, what's 9 times 4? 36. And that one's easy, right? We can take the square root of 36. What is it? 6. I found my y and x. And that's really the last type of problem. Let me look at your worksheet. I may do some with you. Let's look at these. This might help us get used to, I guess it's set in proportions. Which one do I want to do? I don't know. Well, let's just do these because I don't want to confuse y'all. All right, which one? You want to do 26? Just start with that one? I'm still going to give you like 1 or 2 to do by yourself. Y'all don't act so bored. So I'll do 26. I don't need to find my altitude, so I'm not doing the altitude, right? This is to find the sides of the triangles. So let's start with the x. I take the length of the whole thing, which is what? 10. Does everybody see that? And I'm going to put it over x. So let me write that. 10 over x equals x over, remember because we always do it that way. And what does the x go with for the little triangle? 1. Now I'm going to set the y one up different in a minute, a little bit different. So then I would what? Cross multiply. So I get x squared equals 10. Is everybody good with that? Then what's the next step? The opposite of squaring something is to square root it. So x is the square root of 10. Is there a perfect square in 10? 1, no. Doesn't go into it. 4 doesn't go into it. 9 doesn't. So that's it. That's your answer for that one. Now let's do the y. Do y'all want me to give y'all a second to write something down? Okay, for the y, again, what's the length of that whole side? 10. and I'm looking for my y. So I put 10 over y equals y over, now on this one, what does the y go with? The 9. Does everybody see that that segment adjacent to it is the 9? So are y'all kind of getting that concept a little bit? I worry about on the test y'all remembering it, but we'll have plenty of examples. So then I get y squared equals 90. Is everybody good with that? I cross multiplied. Then what do? I square root, same thing over and over again. Now what times what is 90? We've already done this problem. 9 and 10. And what is the square root of 9? 3. There's your answer. Y is 3 square root of 10. Y'all want me to do one more? Yeah? Okay, so I've done 26. Now I'm going to do 27 because one of the things 27 wants is the what? Altitude. So I'm going to use that little altitude thing. Here's number 27. Oh, there it is. So the altitude, I'll square it. That's y squared equals, and this one we multiply those two segments. What's 2 times 6? 12. And then I square root both sides. Does 12 have a perfect square that goes into it? Here's your list of perfect squares. 4. 4 goes into 12. So I'll rewrite that. 4 times 3. What is the square root of 4? So I bring that out, 2, and there's my square root of 3. That's my y value. Is everybody good with that? So the altitude, that's how you find that one. So in a second, I'll give you one with an altitude. Now let me find x. So when you're trying to find the side of the triangle, you take the length of this whole thing. What is it? 8 over x. And then I'm going to flip it, equals x over, and what side does the x go with? 6. That's the little segment next to it. So I get, if I cross multiply, x squared equals 48. See how we're doing the same numbers over and over again? These are most likely the numbers you'll see. So the square root of 48, what goes into 48 that's a perfect square? 16 times 3. And what's the square root of 16? 4. Now, I just want y'all to do 2 problems and then we'll be done. Y'all are going to do number 29 and 31. No, not 31. It has a Z. Hold on. I want y'all to do definitely 29 and maybe just that one. Just do 29. I don't want to give you one with a Z. Oh, yeah. So y'all are doing 29. Is that enough for you to see? Or yeah, okay.
So do we do X or Y first?
It doesn't matter because you can do whichever one.
So for Y, do we like to add?
The y, you square the y and you multiply those other 2 numbers. When you're finding the altitude,
Do we add 6 and 14?
you multiply. Going on to this small lesson, the first thing that they tell is we have this triangle. Actually, we have 2 triangles there, right? A small one and a bigger one. Are y'all paying attention? And what they tell us is that those 2 bases are parallel. Can y'all see that? It should be kind of obvious. And if you know that, then you can set up proportions. And it's saying that this little segment over this bigger segment would be equal to, did I do that right? This little segment over that bigger segment. Does that they're just saying it's proportionate. Again, if I was to, let me point to it with my pen. This little piece of the triangle over that piece would be equal to this little piece over that piece. Yes, no, I mean, that's it. You're just kind of piecing triangles and parts together. I think that's the only one. Let's see. Then they give us, I'll go ahead and show you this one as well. All right, this is the other thing. Knowing all these parallel pieces, this kind of looks like 1 through 6, right? And they're just saying, again, it's common sense. If I know all these lines are parallel, then I can say that if I put AB over BC, that's equal to WX over XY, and so on. Do you see how you can just compare the pieces together? Yes, no? So look, let's look at our worksheet, huh? So let me see. If they tell me that A, this piece over this piece would equal what piece over F? And you're right, it's D. Do y'all see how it's kind of common sense? Like you're just kind of making proportions. You can use all sorts of ways. So on number 2, they tell me F over E is equivalent to C over what? B. Is there anybody who did not get B? Okay. Y'all try number 3. And I'll do number 4 in a second. That's the only one I think is a little bit different. And let me do number 4. A is to what? I don't know yet, but let me look. B to E. If I'm going from B to E, what does the A go with? D. Okay, see, that one was just kind of sideways. But see how you're just making different proportions? Since you have parallel lines, you can make those. So now y'all should be able to do 3, 5, and 6. And then we're going to use that with numbers. And I'll do some examples from the book. Those weren't so bad, were they? No, not as bad as what we did earlier. Where's my notebook? All right, while y'all finish those, I'll write this problem down. I wish I was better at drawing triangles. And what, again, we have to know is this parallel segments. All right. So using what we learned, ignore that. That's from earlier. I would say this one's kind of like the next part, 7, 8, and 9. I'm going to say that the x plus 1 goes with the 12. Does everybody get that? My little segment. And then the bigger segment, x plus 1 over 12, I'm just making proportions, equals what? What do I write next? X over 9. Is everybody good with that? Then what do I do? Cross multiply. So what is 9 times all of that? Both of those things. 9x plus 9. And then I have 12 times x. So what do we do on this one? Subtract the 9x. Is everybody okay with that? So I get 9 equals 3x. Then what? Divide 3. And there's our, I found x. That's what we wanted. Solve for x. Do we need another one of those? No? We're okay with that? Do y'all want to try 7 and 9? Try 7, 8, and 9. Huh? Oh, good. So the next part, I'll show you this picture if I can. There it goes. It's coming back. It's just very blurry. Can y'all see that better? Yay, there we go. I want you to find different measurements. Maybe like I want you to see what is this measurement of site C. Okay? And it's proportionate. You're just going to set up a proportion. Like the 7.2 goes with the what? The 8. Does everybody see that? Yes, no. And what does C go with? the 6.4. So I would just set that up. Do we kind of get that? Did I press resume? I did. So I'm going to put 7.2 over 8, and then I'm going to put equals C over 6.4. Do y'all see how I could set that up and cross multiply? Yes, no, blank stares. Yeah, I got to get that. Okay, so let me do that. I forgot the numbers that I said. 7.2 over 8 equals C over 6.4. Then what do I do? Cross multiply. So what is 7.2 times 6.4? 46.08. And what is 8 times C? I would write what? 8C. Then what do I do? Divide by 8. And what is C? Yeah, 5.76 or 5.8, depending how they wanted their answer, and it's in yards. So site C is about 5.8 yards. Okay, if you were looking back, trying to figure out what it is. Okay, let's see what else they might want. I guess that's enough on that one. Look at number 10. Can y'all handle doing number 10? And I think you could do number 12. Try 10 and 12. I'm going to have to do number 11 with you. It's a little bit more difficult. All right. Try 10 and 12. 12 maybe, I don't know, might be a little bit difficult too, but we'll see. If y'all get stuck, I'll help you out. Let's do number 11 because it looks way more difficult. I'm not really even sure. I know. I'm pretty sure it might have factoring involved. Raise your hand if you remember factoring.
Like where you gotta break it down?
Yeah. It's a little bit. I don't know for sure that it does have factoring. It just looked like it would, so I'm gonna go with it. Anyway, if I set it up, what is the x with? The x over what? Okay, I'll do the x over x minus 2. So I must keep it consistent. And if I set it up that way, then I must do the x plus 4 over what? 9. If you didn't set it up that way, you would still, when you cross multiply, get the same numbers multiplied together. So the first one's easy. What's 9 times x? 9x. The next one, not so easy. I have to take that x minus 2 and multiply it by x plus 4. Do y'all remember how to do that? You're basically distributing. I called it FOIL method. Remember? First, outer, inner, last. This is getting into, I'm trying to think if we need all this for the next chapter. I can't remember. But first, outer, inner, last. So what is x times x? X squared. What is x times 4? 4x. What is negative 2 times x? Minus 2x or negative 2x. And then negative 2 times 4 is a negative 8 or a minus 8. And I'm just going to bring down my other stuff. How are we so far? Good? Now, I'm going to combine these two. What is 4x minus 2x? 2x. And I'm bringing everything else down. Are we good with that step? Now, I don't know if y'all remember factoring. I honestly can't remember how far we got in Algebra 1. I'm pretty sure we factored. A little bit at least. But I set this equal to 0. Do y'all see how my 9x is over here and my 2x is over here? I need to bring it over here with it, right? So let me subtract it over. Are we good with that? So over here I get 0. That's perfectly fine. It's really what I want. And what is 2x minus 9x? Negative 7x. Now the factoring part. When we see a that means 3 terms. One's a squared, one's just the x, and the other is a constant number. We do this thing where we have 2 parentheses. Yes, we remember that? No, we don't. Now, what times what is x squared? X times x. So that's what goes at the front. What times what is negative 8? Y'all give me some numbers that multiply to give me a negative 8. A negative 2 and a 4. Or some of y'all, I think, said a negative 4 and a 2. Is there anything else? A negative 1 and an 8. Or a negative 8 and a 1. What of those adds to my middle number? What adds up to give me a negative 7? It's negative 8 and a positive 1. Are we good so far? Are we okay so far, at least?
Yeah, I mean, I wouldn't have.
Yeah, I know y'all would. That's why I said I'm doing this with y'all. Y'all, they don't even give you an example like this in the book, but for some reason they have it on the worksheet. Maybe it's just a refresher. Now, to find my two answers, there's two answers that x can be. All right? And this one's really weird why they do two answers. So if I set these both equal to 0 is what I'm going to do. Because if this was 0, everything would go to 0. If this was 0, everything would go to 0. So that's what we're saying. Either this is 0 or that is 0. So what's my x going to be? And it's always the opposite of what's in the parentheses. It's going to be 8 and negative 1. If I move that over, x would be what? 8. And if I moved the 1 over, what would it be? Negative 1. Or you can just think, what minus 8 is 0? 8 minus 8. What plus 1 is 0? Negative 1 plus 1. Or you can shortcut it. It's just the opposite. It's going to be 8 and what? Negative 1 are my answers. Let me see what they tell you if they want us to check it. What number was that one? 11. So they did check it, which means they plugged it in, I guess. I don't know. Oh, you don't have to check it. Can x be negative 1? Look right here. Can that length right there be negative 1? Does that make sense? No. So it has to be which one? 8. Okay? Y'all, there will most likely not be one that difficult on the test. I'm telling you, it wasn't even one that difficult in the book. That was 11. And y'all, I'm just going to do 2 more problems and then we'll be done. I'll do these with you on your worksheet, okay? Then we'll call it a day. So the next one, I'll show you. This is what they do. I'll just show you the little theorem, and it's just easier me doing the problem. But it just says, if this triangle is bisected, then you can divide it into parts. You can just set up the proportions. So they said this bottom piece over this piece equals this side over this side. And again, you can set your proportions up probably a lot of different ways, but let's just dive into number 13. Okay, I'll try and write it on that paper. Number 13, if I put x over 9, all right, I'm just going to look at my 2 little triangles. If I put my x over my 9, what would come next? 16 over 12. Is it kind of common sense by now on setting these up? We should be getting used to it. So I would get what? 12x equals, what's 9 times 16? Oh, what'd y'all get? Okay, because I did something wrong on my calculator. And then I divide by 12, and what does x equal? 12. Okay. Number 14, we can do, that one's going to be a little bit hard. Let's do 15. I think that's one I want to do. If I did 6 over 9, I would set that equal to what? Oh, sorry. X minus 4 over x. See how I just split those parts, those pieces up? And then we cross multiply. So over here I get 6x. And what do I get on the other side? 9x minus 36. Very good. Okay, then what? Subtract 9x. Let's move it over here. Negative 3x equals negative 36. Then what? Divide by negative 3. And what is x going to equal? 12. There we go for that. Okay. And it could be that I don't know, we have 10 minutes. Maybe I'll just do one more where we factor just for practice. Okay, and then we'll be done. I know I told y'all to. Y'all pick. Do y'all want me to do 14 or 18? They're about the same. 18. Okay, here we go. I'm going to do it on a separate sheet of paper, but that's what 18 looks like. Y'all can look at it. I would say that x over x minus 2, x over x minus 2 equals what? How would you set up the next part? Well, if I did the x first, 2x plus 3 would then go over what? X plus 4. And then, y'all, this one, again, I'm going to cross multiply, but it's going to be where we have to distribute on both of them, okay? So this one is a very difficult one. Good Algebra 1 practice. So I'm going to write it x times x plus 4, and then I'm multiplying these two. Sorry, I'm letting people know that game is canceled. Okay, so I distribute. This one's easy. It's not full method. Do we see all I have to do is multiply the x? So I get x squared, and what's 4 times x? Just 4x. Not bad. Now, this one's FOIL method. Are y'all warm? No? Okay, I'll leave it on then. So I will do x times 2x, which is what? 2x squared. X times 3 is what? 3x. Negative 2 times 2x is what? And then negative 2 times 3 is negative 6. Now I shall combine my like terms right here. Okay? I'm just going to bring these two things down for now. Bring down my 2x squared. What is 3x minus 4x? It's a negative 1x. Is everybody good with that part? I just combined those two things. Now, I need to move these two things over here, right? I'm going to bring all of these to one side and set it equal to 0. So I subtract my x squared. And what else am I going to move? My 4x. So I'm going to go ahead and write that. Let me subtract my 4x. So over here, that all goes to 0. And what is 2x squared minus 1x squared? 1x squared. And negative x minus 4x is what? Negative 5x, and then a minus 6. Then what do? We factor what goes at the front. X and x. And now I'm going to see what times what is negative 6. Well, the obvious, negative 2 and 3. And then I also have this, the 1 and the 6. What adds up to a negative 5? That does, right? Negative 6 and a positive 1. What are my two answers? The opposite, right? My two answers are what? 6 and negative 1. Do y'all remember that? It's the opposite of them. Do y'all understand why? Yes, no? Now, are both of those the answers, or is one of them not going to make any sense? This one does not make sense because you can't have a negative length, okay? And that's going to end up with a negative length. So your answer is just 6. Everybody does understand where the 6 and the negative 1 came from, though, right? Yeah, okay. Because that's what would make those go to 0. All right, that's it. We're done. If on your test program, yeah, I'll take it. We won't worry with the. If your program has one of those on it, listen, I might make that a bonus question. Okay? I don't ever do bonus, but I might make that a bonus question.